Hi, and welcome to our poster. I'm Deanne Fay. I'm an international classifier with World Parathletics and a professor of physical therapy at A.T. Still University in the United States. Today, myself, along with my colleagues listed here, would like to present to you our research poster titled Component Analysis of Broad Jump, Triple Hop, and Bound Activity Limitation Tests used in Para-Athletics Classification in Individuals Without Impairments. So to have a little bit of the background, during athletics classification for ambulatory athletes with coordination impairments, activity limitation tests are used. There are 5 activity limitation tests in total, and these were introduced in 2018 and are now a regular part of the classification process. This research is going to focus specifically on broad jump, bounds for distance, and triple hop for distance, as these are 3 activity limitation tests that have been found to be most predictive of sprint speed. Based on this, there's a need to gather more information about the normal performance of these tests so that classifiers can make evidence-informed decisions during the classification process. Specifically, this study was designed to analyze the movement components during performance of these 3 tests in individuals without physical impairment, to provide normative values, and to determine which components are most highly correlated with test performance. So the results of this study are part of a larger study. The initial findings are presented in another poster that we have at Vista this time, and it's called Reference Values in Individuals Without Impairment for Activity Limitation Tests Used in Para-Athletics Classification. The basic methodology for the overall study is described in depth during that poster presentation, so I'll hold off on doing it here and focus instead on the specific part that's different for this portion. And that is that for this portion, we did video analysis using Dartfish video software to allow us to look at specific component lengths and joint excursion. So each participant performed each of the activity limitation tests 3 times. 1 as a practice and 2 at maximal effort. Those maximal effort trials were videotaped, and you can see here video that was taken from a sagittal view that got far enough away that you could see the full components of movement. You can also see then down below other examples of a preparation at a broad jump or a landing during a triple hop. These videos were uploaded into Dartfish and analyzed for joint excursion. For the broad jump, we had 2 trials for each subject, those 2 maximum effort trials, so we ended up with 144 videos total. For bounds and for triple hop, we actually had dominant and non-dominant sides, so we had 4 trials per each individual, resulting in over 280 videos. In terms of the joints that were analyzed, we looked at hip and knee flexion during the preparation phase for broad jump, and then also during the stance and swing limbs for bounds and triple hop. And for each time that we were looking at a max flexion or an extension, the point taken where maximum flexion or maximum extension was achieved was used for measurement. Joint locations were determined based on prior research by Norris and Olson to use instead of, as we didn't have specific joint markers, but our inter-rater reliability across researchers for all of the joint excursions was excellent with an ICC of 0.998. We analyzed our data for normality using a KS test. We did reliability using the interclass correlation coefficients, and differences between trials and between hops was determined by the generalized estimating equations. These differences then helped us understand when we could combine data for looking at correlations between range of joint motion and the distance achieved. Non-significant differences and any differences, even if they were significant that were under 5 degrees, were combined for the correlations. Okay. So going back up to the top of the poster to take a look at the results, you can see here these top graphs are showing you results for the broad jump. And in the broad jump for maximum shoulder and hip flexion were both positively and moderately correlated with the distance achieved by the jumps. So this graph here is showing you the correlation for shoulder flexion. The one for hip flexion looks very similar. The middle graph is showing shoulder extension, and you can see that this was not correlated and gave us an R value of 0.08. Knee flexion, interestingly, was actually negatively correlated. It was an R value of minus 0.43, and you can see the negative relationship there. Moving to bounds. For bounds, the only joint that showed a positive correlation was the maximum hip flexion achieved in the advancing limb. So as a leg was swinging out to take that next step, the maximum hip flexion, and then along with that, the overall hip excursion showed positive correlations. The other joints did not show any significant correlations with overall bound distance. For triple hop, we looked at both stance and swing limbs. So the graphs right here on the left are for stance. We found positive and moderate correlations for hip extension, hip excursion, knee extension, and knee excursion. Because the hip extension seems to be the key part of that excursion, we are showing you the graphs here for the relationship for hip extension, and the bottom graph is the relationship for knee extension. The graph over here on the right is representing that maximum hip extension and hip excursion in the swing limb was also significant with an R of 0.31. These graphs highlight the key findings, but if you're interested in more of the detail, you can use this QR code and it will bring you to a data sheet that we have included. This data sheet has tables for you to give you the actual mean and standard deviations of each of the joints for each of the different tasks. We've highlighted in yellow the ones that were significant with at least a moderate Pearson R. And then you will see on some of the graphs, tables, excuse me, here, where you can see how we took the initial, like this is showing bound 2 and bound 3, whether we could combine the data or not. Anything in blue indicates it was significant, but under 5 degrees. The ones in pink indicate a difference greater than 5 degrees that was significant. And so those were then analyzed separately for the correlations. So what does all this mean in terms of information for our classifiers? Well, we identified before that these 3 tasks are specific for having higher predictive value of sprint speed. What we're hoping here is to kind of show you what are some of the important components to look at for classifiers when they're analyzing those specific tasks. So classifiers might want to select the joints that had the highest correlation with task performance when analyzing their athlete's performance during the classification process. So to summarize what those are for broad jump, hip flexion and shoulder flexion both had positive correlations, and this is also consistent with findings in the literature related to angle of takeoff and arm movement. The negative correlation with knee flexion was not necessarily consistent with previous literature, as that showed increased velocity at takeoff with 90 degrees versus 45. But our values that were relating to shorter distances were actually above 90. So classifiers might want to look at athletes that are not flexing enough or are flexing too much. For bound, it was clear that the hip flexion of the advancing limb appears to be the most important motion related to overall bound distance. And for triple hop, you want to look at hip and knee extension in the stance limb and hip extension in the swing limb to predict overall triple hop performance. One important thing to note is that this study did not include analysis of the ankle, as we weren't able to reliably measure that with the dartfish software and the angle of which we took the video. So we recommend future research would want to look at that for a full picture. Thank you again for taking your time to look at this and your interest in our topic. We hope that you will reach out to us if you have any questions. My email is here on the poster, dfay@atsu.edu, and we'd love to hear from you for further discussion. Hope you enjoy the rest of your conference. Thank you.